Now we move on to other examples. To motivate these other examples, that is the case of rational expressions where the denominators might have some or no factors in common, we would like to remind ourselves of how to find the LCD of 5 and 7. Take note that these two numbers are not the same numbers, and 5 does not divide into 7. So how would we find the common or the least common denominator of 5 and 7? One way I would suggest to do that is to take the bigger number as a seed for your thought process. How do I mean? 7 times 1 is 7. Will 5 divide into 7? No. What about 7 times 2? 14. Will 5 divide into 14? No. 7 times 3? 21. 7 would not divide. Not so. What about 7 times 4? 28. 5 will also not divide. And what about 7 times 5? 35. Well, 5 will divide into that. Voila, that's what you want. So the LCD of 5 and 7 is 35, and that is the lowest multiple of 7 that 5 can divide into. Again, the lowest multiple of the bigger number that the smaller number can divide into. Let's use a similar thought process for question B. For 10 and 16, 10 would not divide into 16. 10 would not divide into 16 times 2, which is 32. 10 would not divide into 16 times 3, which is 48. In fact, you will have to get to 16 times 4, 10 will still not divide. 16 times 5, 80. Oh, yes, 10 will divide. So, it means that the LCD of 10 and 16 is the smallest multiple of 16 that 10 will divide into. And that is 80 in this case. What about 3, 5, and 7? Sometimes it might prove a little difficult to find exactly, or it might take a longer time to find a multiple of 7, or the biggest number that the two smallest numbers can divide into. When that happens, one of the things you might, or one of the last resorts that you might have, is to take the answer to be 3 times 5 times 7, which is 105. This would be the least common denominator that all numbers can divide into. For example, 3 will divide into 105 35 times. 5 will divide into 105 21 times. 7 will divide into 105 15 times. Now that we have reminded ourselves of these basics, let's now go on into further examples on addition and subtraction of rational fractions. So, we begin. We have x minus 2 and x plus 2. These are the denominators here. So we need to construct the LCD. The LCD will be the distinct element here. You have x minus 2, and then you have x plus 3. So, in this case, we have to examine how each of the fractions will catch up. So you have 2 all over x minus 2. You agree that this needs an extra source of x plus 3, both at the top and on the bottom, so that the bottom can catch up with the LCD. So we're done with the first fraction. Then, for the second fraction, 5 over x plus 3, for this to catch up with the LCD, it needs an extra source or extra element of x minus 2. So you have x minus 2. And then, with that said, now that both denominators are exactly the same, we know that this means that on the next line, we can write our LCD, which is x minus 2 times x plus 3. And so on the top, we're going to have 2 times x, 2x, and 2 times 3, which is 6, plus 5 times x is positive 5x, plus 5 times negative 2 is negative 10. And so with that said, we are ready to simplify the numerator by combining like terms. 2x plus 5x is 7x, plus 6 minus 10 is negative 4. And in which case, we observe that this will not factor any further. So this tells us that this is the final answer. 7x minus 4 all over x minus 2 times x plus 3. And with that done, we move on to the next example. We are to add 4 all over m plus 3 minus 3 all over m plus 4. The LCD will be the product of m plus 3 and m plus the two distinct components here. That will be m plus 3 and m plus 4. So that means 4 all over m plus 3 compared to this needs an extra m plus 4 on the bottom and on the top, minus 3 over m plus 4 needs an extra m plus 3 on the bottom and on the top so that the bottom can catch up to the LCD. And so with that, we are ready to write the bottom, which is m plus 3 times m plus 4, and then 4 times m, 4m, 4 times 4, 16, negative 3 times m is negative 3m, negative 3 times 3 is negative 9. And with that, on the top, we combine like terms. 4m minus m is m, 16 minus 9 is positive 7, and divided by m plus 3, and then m plus 4. And that is the final answer. Then we proceed to the next example. For the next example, we observe that the denominators are each a quadratic expression. And so we'll need to factor each of them. If we factor x squared minus 2x plus 3, we'll have x plus 1 times x minus 3. Plus, to factor this guy, we're going to have 3x all over x plus 3, and then x plus 1. Now that we have factored each of the terms, or each of the numerators, we have the recipe or the ingredients to build the LCD. We need x plus 1, which is already accounted for. We need x minus 3, and we need x plus 3 to accommodate all different distinct components. And from that level, we are ready to say that 8 over x plus 1, x minus 3 needs an extra component. And that will be, we already have x plus 1, x plus 1, x minus 3, x minus 3. We only need x plus 3 for this extra component to be complete. Then plus 3x all over x plus 3, and then x plus 1, in which case you already have x plus 3, we already have x plus 1, so we only need x minus 3. So the denominator here is the LCD, which is x plus 1, x minus 3, x plus 3, and we can now focus on the top part. So, for example, 8 times x, 8x, 8 times 3, positive 24, Positive 3x times x is positive 3x squared. Positive 3x times negative 3 is negative 9x. And so we have in this case 3x squared, and then 8x minus 9x is negative x, and then plus 24 divided by x plus 1, x minus 3, and then x plus 3. What you would observe is that the top does not factor any further, and so this is the final answer for that question. Now we move on to the next example, in which case you have 3 all over z plus 3 minus 6z all over z squared minus 3 squared. So that is the case of the difference of two squares. And so the LCD in this case will be z plus 3, accounting for this piece, and then times z minus 3. So with that found, we can then compare each fraction to the LCD. Does this need an extra element? Yes, it needs z minus 3. So we have z minus 3. And so we look at the next fraction, and comparing the denominator of this fraction to the LCD, or with the LCD, you observe that they already match, so we don't need any extra component for this fraction. Now that we have this set up, we can easily see that the two denominators match with the LCD, and so we can write the denominator for the final fraction on the way and concentrate on working with the top. So you have 3 times z, 3z, 3 times negative 3, negative 9, negative 6z, negative 6z. And with that said, 3z minus 6z is negative 3z. Then minus 9 divided by z plus 3 over z minus 3. Can we factor anything from these two? The correct answer is yes. We can factor negative 3, z plus 3 divided by z plus 3 times z minus 3. So this cancels this, and so the final answer is negative 3 all over z minus 3. Now we go on to the next question, in which case this numerator can be factored into negative 2y plus 1 divided by the denominator here can also be factored into y minus 2 and y plus 4 minus, here you have y minus 1 all over 2 minus y. It is time to observe the denominators. You have y minus 2 here. You have 2 minus y here. These can be rewritten as negative 1 y minus 2. Do you recall? So, in which case you have negative 2y plus 1 all over y minus 2 times y plus 4 minus y minus 1 all over negative 1 times y minus 2. And so we anticipate that in the next step, this negative and negative will blend to become positive. And so that's what we have exactly. So you have y minus 2, y plus 4, and then this becomes plus y minus 1 all over the remaining y minus 2. With that said, the LCD then will be y minus 2 times y plus 4. And so That tells us that the first fraction, since the denominator matches exactly the LCD, does not need an extra element or source to it. However, the second fraction has only y minus 2, so it needs an extra y plus 4, both on top and on the bottom. So what do we have? We have the fraction where the bottom is the LCD and the top is negative 2 times y and negative 2 times 1. So negative 2 times y is negative 2y. Negative 2 times 1 is negative 2. And then you have positive the product of these two. So what will be the product of y minus 1 times y plus 4? That will be y squared plus 3y minus 4. So this will lead to y squared and then negative 2y plus 3y is positive y. Negative 2 minus 4 is negative 6 divided by y minus 2, y plus 4. Note that this factors even further into y plus 3 and y minus 2 divided by y minus 2 times y plus 4. So that cancels out and you have y plus 3 divided by y plus 4 as the final answer.